Okay, cool. I did not mean to raise my hand. All right. I'm gonna go over I'm going over one of the problems he went over in class because this one I saw was pretty tricky when I was going over it and everything. And I have one more problem that I was planning to go over. So never mind, I chose the wrong problem. That was an incorrect problem. Oh well. All right, I'm gonna go ahead and start this one. So this is related rates. So when one thing changes, it affects other things. That's why they are related together. So in this problem, a particle P moves clockwise at a constant rate along a circle with a radius at 10 meters centered at the origin, meaning that the radius is always 10 meters, so that's your constant value. That's a constant value. It will never change. The particle's initial position is 0, 10, so on the y-axis. That makes your life a little bit easier. And its final destination is at 10, 0 on the x-axis, which is basically just 1/4. Once the particle is in motion, the tangent line P intersects the x-axis at point Q. So, which means over time. So point Q is constantly changing. If it takes the particle 30 seconds to travel from start to finish, how fast is point Q moving along the x-axis when it is 20 meters from the center of the circle? All right, so let's start out by drawing a graph. I'm just going to draw the first quadrant. Let's move it over here, actually. Whenever you're solving these problems, it always helps to draw a picture so you can see. So you have a circle. And this is 10, 0. And this is 0, 10. And you have a point P that is somewhere on the circle, but it has to be on that line. If any of y'all get confused by anything, please just ask a question. So we have a point P, and then we have a tangent line. Let's make that color. Then we have a tangent line that goes like this. We don't know the direction of the tangent line, but here's point Q. Now we know that P is moving in this general direction along the line. And so we can deduce from that. It starts right here. And this is 10 meters, one of your constants. And this is theta, your angle. So you have your constant, you have your angle, and we know that when this moves this way, while this is moving to the right, Q will be moving this way. So Q is moving inside as the angle goes down, because the slope of the tangent line will get closer and closer to infinity. So it'll be getting closer and closer to pointing straight up. And once it hits this x-axis, it is infinity, so it will be straight up. All right, so theta is changing. Theta is changing, so it takes 30 seconds. Come on, tablet. It takes 30 seconds to travel from start to finish. So for this whole thing, it takes 30 seconds. So 90 degrees. 90 degrees and 30 seconds. Which equals 180 degrees per minute, which equals pi radians per minute. Math wants everything done in radians, so I suggest getting everything done in radians. I just like using degrees because it makes sense. And it's a constant rate. This string protector is going to drive me insane. So now we know d theta dt equals pi radians, or negative pi actually, because it's moving to the right. So it's negative 90, negative 180, and negative pi per second. Because, you know, when an angle opens up, it goes counterclockwise, it gets bigger. So when it goes clockwise, it's getting smaller. So you have to do negative. So that's one piece of the puzzle. Now, we have to find this distance. So I'm just going to draw this down here again. We have Q. And say we have and let's say the distance between them is x. Well, we got a problem. We don't know that x. But if you can see right here, the tangent line always makes a 90-degree angle. So if we work with that, since this makes a 90-degree angle, we know this is 90 degrees. All right. And if you imagine, so now we have a triangle that looks like this. If you flip it up on its side, 90 degrees because we rotated this around. You have 10 meters. At the bottom is actually no, that's wrong. Is 10 meters x, and this is technically 10 plus q, but you don't need to know that. Actually, no, sorry. It's hard to work with this, twisting that around. Let's say we twisted it to the left. Yeah, this is hard for me too, guys. Trust me. And your hypotenuse is x, the total x. All right. Actually, it's actually x plus 10. So let's just say change this down here. X. So now you have a triangle. This is x. This is 10. And this is just an arbitrary value that you don't need to know. So if everybody following along hadn't warned me of a message. Okay. Oh yeah, sorry, I missed that. It hadn't been warning me. So you had negative 90 degrees in 30 seconds, so negative 180 degrees per minute. It gave it to you in seconds. You can solve it in any seconds because it gives it to you in seconds, but minutes, it just makes the thing a lot easier because I really don't want to divide pi by 60. Sorry, I missed that question. Yeah, this is why you need the whole thing. When it's 20 meters from the center of a circle. So you want Q to be at 20, 0. Anyway, so now, sorry this is cringy, guys, I know. Cosine theta equals adjacent over hypotenuse. So cosine theta equals 10 meters over x. Because when we rotated this around, this is theta. So we have theta. And we have x. So the adjacent is 10. And x is the hypotenuse. All right. So now what we can do is solve for x, because that's what we need to know. So x equals 10 over cosine theta, which equals 10 secant theta. What's cool about this one is we're going to know what 6 is, but x is the change in distance, or the total distance. We want to know the change in distance, all right? Because the question asked us, how fast is the point Q moving along the x-axis? So we want to know the change in point Q, and that's x, this distance x. So dx dt, so x equals 10 secant theta. Dx dt equals 10 times secant theta tangent theta times d theta dt, because theta is a function, not a variable. And we know what this is. So we just plug in our value. Actually, now here's the hard part, the really hard part. So dx dt equals 10. And d theta dt, if we go up here, negative pi. Now what is theta? That's the real question. When he solved it, he used some funky method, but what's cool is we have x right here equals 10 secant theta, right? From this equation up here. Well, what's cool is we know what x is. It gives us x right here. And because it gives us x, we can plug that in. And now we only have one known, so 20 equals 10 secant theta. Divide both sides by 10. So secant theta equals 2. So 1 over cosine theta equals 2. So cosine theta equals 1/2. Theta equals pi over 3. I'm assuming. It could be negative pi over 3, but now, but what's cool about this too, though, did you see secant theta? The secant theta right here. So you didn't even need to go through this, but this helps when you go solve for tangent. Now, what the professor did was he used the Pythagorean theorem, which is probably easier if you recognize it, but not many people are going to recognize it. So now that we know what theta is, so now we can do so sine of pi over 3 is √3 over 2. And cosine of pi over 3 is 1/2, which equals √3 over 1, which equals √3. So now You got tangent of theta equals √3, and you have tangent of theta. Would y'all want me to go over what he did? Explain like his mindset for how he solved it after I do this real quick? So now you have all your values. So now you just leave everything like it is and just simplify. So that's how I did that. Do y'all want me to go over his method? That was a long problem. All right. So what he did is he knew what secant squared was, right? Or secant theta. I'll just keep it in green. Theta equals 2. He solved for that. So he needed an equation that he only had one unknown. So he chose the Pythagorean theorem. It's Pythagorean theorem. It's based off of if you divide everything by cosine squared and subtract the left from the right, you get this equation. So what this equals 2 squared minus 1. So equals 3. Y'all know what 2 squared is. So we take the square root. There. Now that that's how he solved that one pretty much. And since he had tangent theta, he didn't need to solve for theta. And this one's wrong. This right is wrong right here. It's in not in radians. It's in meters per minute. So any questions over that problem? That one was a little lengthy. If there's no questions, I'm going to move on. I had a second one planned, but it messed up. Apparently, I grabbed the wrong file. All right, y'all ready to actually talk to me? All right, for this problem, y prime equals the derivative of y equals x cubed minus 8. That's what this problem's saying. So, remember that formula I told you? When f prime of x equals n(a) to the n, or n(x) to the n, f of x equals n, oh no, it doesn't have to be n, let's just do a, because they could be different numbers, times 1 over a plus 1 times x to the a plus 1. Because when you're taking the derivative, you're subtracting 1, but this time you're going backwards, so you have to add 1. And instead of multiplying, you're dividing. So knowing that, we have 1 over 3 plus 1 times x to the 3 plus 1 minus 8 times 1 over 1 plus 1 x to the 1 plus 1 plus, what do we put here? What's in all of these equations? C. C is an arbitrary constant, meaning you can have any constant there from negative infinity to infinity as long as it's a real number, and this would work. So it ends up equaling x to the fourth. I forgot that. Oh, never mind. No, I didn't. I had that right. I was looking at that. I was like, it was a problem. X to the fourth over 4 minus 8 over 2x squared plus c, which equals plus c. So you didn't even simplify this one. Those simplify, but yeah. The correct answer here is D. Any questions over that? Is that little formula right there helps out. All right, so right here, we got to do the same thing. F of x equals 1 over 1 plus 1 minus or times x to the 1 plus 1 minus 1 over 0 plus 1 6x to the 0 plus 1 because it's understood 0 plus c. So it ends up equaling 1/2 x squared minus 6x plus c. That's your equation. But you have a point. Yeah, so you have p 3 negative 8. Whoops. So since we have a point, what do y'all think we can do with this? Correct. So this is first coordinate your x, second coordinate is your y. Your y is on the left side, so negative 8 equals 1/2 times 3 squared minus 6 times 3 plus c. So negative 8 equals 9 over 2 minus 18 plus c. So 10 minus 9 over 2 equals c. C equals, that's 20 over 2 minus 9 over 2 equals 11 over 2. So f of x equals 1/2 x squared minus 6x plus, we have our c, 11 over 2. Any questions? All right. Use the graph to locate the local extremity and identify the intervals where the function is concave up and concave down. All right, so you don't have an equation, so you can't do the first and second derivative test. But if you can see here, it's increasing, increasing, increasing. Then right here starts decreasing. And that whole time, it's kind of sort of pointing downwards. Right here, it's decreasing, and all of a sudden it starts increasing again. But it's like a bucket, so it's trying to capture the rainwater. So it has a local maximum at x equals -1 right here, right? Because it starts from decrease or increasing to decreasing. That means a maximum. And it has a local minimum right here because it goes from decreasing to increasing. So all these first options, like first parts of all these, you can't eliminate anything. Now concavity, that's just part of the second derivative test, but it's facing downwards. And you can see I kind of colorfully marked it right here. This one is facing downward all the way until you get to 0. Can y'all see that's kind of where it shifts? It's not at a vertex or anything. It's kind of in the middle. Not always, but. But now that we know the concavity is concave down from negative infinity to 0, and concave up from 0 to infinity. Therefore, your correct answer right here is B. Any questions on that one? Graph the equation, include in accordance with any local or absolute extreme points and inflection points. So he wants you to graph it. So first thing we need to do, in my opinion, well, you can find the zeros. So x. So now you know there's a 0 at x equals 0 and a 0 at x equals negative 10. That quick by factoring. I'd always start by factoring. Let's actually do that in red. So now we need to find the extreme point. So we'll find the derivatives. Use the power rule. And so now draw your number lines. We set the first one equal to 0, or the first derivative. X equals negative 5. It's positive all the way through. It'll never change. It'll never equal 0. So you don't have any inflection points in this graph. Obviously, it's a quadratic, but still. So now you plug in a number less than negative 5. So let's plug in a number less than negative 5 to the derivative. So let's plug in negative 10 to the y prime, and you get negative 60 plus 30, which is negative. Let's plug in a number greater than negative 5 to the derivative. So let's plug in 0. So 6 times 0 is 0 plus 30 equals positive. Remember, the derivative. And no matter what we plug into the second derivative, it's always going to be positive. It's going to be positive 6. So now we know, I mean, he showed y'all the first and second derivative test. That works for when you have inflection points, but for most of the time, most general cases, I don't know how he's going to test this, but most general cases, if this goes from decreasing to increasing, that means there's a local minimum. So keep that in mind. Doing the full test is kind of a waste of time unless they specifically ask for it. So negative 5. So if we plug in y at x equals negative 5 equals 3 times negative 5 squared plus 30 times negative 5, which equals negative 75. That's your minimum. Now, since you only have one change in direction from decreasing to increasing, that means your minimum is an absolute minimum. So you have an absolute minimum at negative 5, negative 75. Here's your two zeros at negative 10 and 0. And say that's negative 5, 75. That's your absolute minimum. It's concave up over the entire domain. Therefore, your answer is A. Also, it's decreasing until it gets to negative 5 and then increasing. Any questions on how I'd solve that one? All right, we'll go ahead. Sketch all the graphs to show local extreme and inflection point. All right, we're going to do the same thing. We're going to try to factor. You may not be able to factor this one. No, you can't factor this one. Okay. So since you can't factor it easily, you don't have to. I just usually do that to make it easier. We'll find the derivatives. So if we set this one equal to 0, so we have 0, and this one goes into -1 and +1. So we have 3 critical points. Let's do this. Set this one equal to 0 now. And since the second derivative is a derivative of the first derivative, you're usually going to have one less point than the first derivative. Some of them can be imaginary. That's not always going to happen, but most of the time you can have one less point. That's how it can help deduce that, because there's one less derivative. So now we have y prime prime. All right, so for the first derivative, so this one is let's plug in -2. So a -4 times a -8 will give you +32 minus 8. It's going to be positive. Let's plug in a -0.5. So -0.5 is going to get really small when you cube it. It's going to stay negative. It's going to be positive. This is going to be 2. Plus 4 times. And it's going to give you a negative value. All we care about is positive and negatives, remember. So positive 0.5 is going to do the opposite effect. This one's going to be negative, but it's going to be smaller. This one's going to be positive, so this is going to be positive. And if you plug in any large number, this cubed and this negative sign, it's going to stay negative and this is going to stay positive, but this gets way bigger, way faster. And you end up with a negative. You can also factor this out, kind of make your life easier. You'd end up with like a negative, positive, like I usually do. I just didn't do it that time. And we have y prime prime, which equals yeah. All right, so a number less than -3, negative square root of 3. I think -2. Yeah, -2 is because square root of 4 is 2. So if you plug in -2, you have -48 plus 4, so that's a negative. That means concave down. You plug in 0, you get a positive. Smiley face. If you plug in regular 2, this is going to be positive anyway. It's going to do the same thing, so it's going to be negative again, concave down. After knowing all that, We know it's increasing from -1 or negative infinity to -1, and it's decreasing from 1 to 0. Everything. I'm not sure about y'all, but I don't think I have time to go through all the finding all the points and plugging them in. So you have absolute max -1 and 1. It's going to be pointing down. And you have a local minimum here at 0. Plug in 0, you get -10. It's either A or D. There's 2 inflection points. It's D. Yeah, sorry, I didn't want to plug everything in. It probably would have been faster if I just plugged it all in. You'd have to plug in those points to the original equations to find the exact spots. Any questions over that? If there's no questions over that, I'm going to go ahead and try to solve number 6. The graph below shows the first and second derivatives of f of x.
Hey, Lance, I have a question.
Okay.
Where do you plug the inflection points at to find the y coordinate?
To find the y coordinate of this one?
Yeah.
I got the wrong inflection. You plug in the x value you got to the original equation.
Okay.
Yeah, I did this wrong. So, you got any more questions?
No, I think I was just confused on that.
Yeah, if you want to find increasing and decreasing, you plug the values into the derivatives. In concavity, you plug into the second derivative. If you want to find the point, the actual value at that x coordinate, you plug it into the original equation.
Okay.
All right, there's that one. Sorry about that. So now that we know this is the first derivative, and this is the second derivative. We know it's concave down until it gets to 0, then it's concave up, and we know it's increasing until it gets to this point, and it's decreasing between these 2 points right here. So let's zoom out. So it's increasing until it gets to about right here. It's decreasing right here, so that one's out. It's got to be increasing on the left because the first derivative is positive. It's got to be it's got to be increasing and concave down. So right away, decreasing. Just by looking at the first derivative, you can get this one easily. But it changes concavity at x equals 0, right? Can you see right here where this one changes concavity? Concave down to concave up, kind of, sort of. And it's right here, your critical points where they change direction. But just by looking for the first derivative, it's not increasing from -infinity to whatever that point is. So the only answer is B. Any questions over that? By looking at the second derivative, this is our second derivative. And whenever the second derivative is negative, it's supposed to be concave down. Whenever the second derivative is positive, so this is a positive y and negative y. And whenever the second derivative is positive, it's concave up. So that's the second derivative test. Any other questions? If there's no other questions, I'm going to move on real quick. Graph the rational function. First things first, see if something cancels out. X squared, so we have x, and it's going to be they both going to be minus 2 and 1. Yep. So now that's your equation. You have, keep in mind, you have a hole at, I scratched out the wrong one. Keep in mind, you have a hole at x equals 2. Leaf blowers, I'm going to kill someone. Can y'all hear the leaf blowers? They're right by my window. Okay, we're going to try to get through this. Sorry. So you cancel that out. And now we have a hole at x equals 2. So now this is our new y. So y also equals, this is a bit easier to take the derivative of. Dear God. Okay, y equals x minus 1 to the negative 1. So using the chain rule, y equals negative 1 times x minus 1 to the negative 2, which equals negative 1 over x minus 1 squared. So now, set this equal to 0. You get critical point at x equals 1 because it does not exist at that point. Oh, what this also means right here is you have an asymptote at x equals 1. Now, if you take the derivative again, you're going to get the same result. So you don't really need to take the derivative because you're just going to get this. You're going to get a negative 2 or 2 on top, and you're going to have an x minus 3 cubed or x minus 1 cubed. So x equals 1. So if you plug in a 0 to the derivative, you get negative 1 over 1 squared, which is negative. If you plug in a 2, you get negative 1 over 2 minus 1 squared, which is negative. So what does that mean? That's weird. So it's decreasing over the entire function. And if you were to take the second derivative, it'd be positive over the entire function. So we know at x equals 1, there's an asymptote. We know at x equals 2, there's a hole, and you have to plug in 2 to the remaining equation. So y at x equals 2, get 1 over 2 minus 1 equals 1. So hole at 2, 1. 0, 2, 1. There's a hole right there. And this is also a JLO. So there's a horizontal asymptote at y equals 0. This is always increasing. Isn't that weird? Or decreasing. Isn't that weird? How is that possible? Well, if you graph it, it's going to look something like this. See how it's decreasing from left to right, slowly but surely? If you graph it right here, it's going to hit there. And then like that. It's always decreasing because you have those asymptotes. Therefore, there you go. C is your correct answer. Any questions on how I did that one? Or any further explanation needed? All right. I hate these lawnmowers. L'Hopital's rule. So if you plug in 4, you get 0 over 0. That's a 6, which means indeterminate. Remember how hard life used to be when you had to try to cancel stuff out? This one's a little easy. But now you can take the derivative. So the limit as x approaches 4 of, say, if we take the, we'll write it over here. Equals the limit as x approaches 4 of 2x over 1. So equals 8 over 1 equals 8. Any questions on that one? That one was fairly simple. You take the derivative of the top and the derivative of the bottom, and you just keep going. And if it's still indeterminate by the time you're done, you keep taking the derivative like that over and over and over again until it works. Eventually, you'll get down to a constant number. Okay, so if you plug in 0 to both of these, you get 0 over 0. So if you take the derivative of the top, so L'Hopital, you get limit x approaches 0 of 4 cosine 4x over 3 secant squared of 3x, which equals 4 times 1. Oh, wait, no. Yeah, 4 times 1 over 3 times secant squared of 3x equals 1 over cosine squared of 3x. So it equals 1 over cosine of 0 squared, which equals 1. 3 times 1. So it equals 4 cubed. Because secant is 1 over cosine, right? Secant is equal to 1 over cosine. Or no, 4. I plugged in 0 to cosine. So it's cosine of 0. Because when you plug in 0, you get cosine 0. And cosine 0 is equal to 1. Yeah, sorry, I skipped a few steps. I'm still trying to hurry. We only got 10 minutes left. But if y'all need me to answer questions, please don't hesitate to ask. So the correct answer there is 4/3. So now this one I saw earlier and I didn't like it. If you plug in 0, everything is to the 0 power. I mean, I would assume it's 1. But it's one of the indeterminate forms he went over today, and I can't quite remember it. I wasn't paying too close attention. You get equals e to the... Oh, this one wasn't on it? That one wasn't on it. I'll go graph it. Because I don't like that question. Because it doesn't exist because you have 6 over 0, and that's impossible to exist. Okay. I'm glad he didn't put it on it. Y'all would have been crying. Oh, there's no way. Okay, it doesn't exist in negative numbers for some reason. It doesn't exist as negative numbers. And apparently it's approaching 20. E to the 6 over x plus 5x, x divided by 2. I put it in right. Unless e cubed is 20. It's e cubed. I figured y'all might like to know that one. So the answer is e cubed on that one. I don't know how to solve it off the top of my head. Sorry. Unless you just take the derivative. What's the derivative of that? It's like natural log of. That's disgusting. Okay. L'Hopital does not. So L'Hopital rule does not help. That's strange. So if you plug in infinity, you get infinity over infinity. You can pull out a x squared or an x from both of them, so you'll get. Was this one on it at least? All right. So you get you plug these, you take out an x to the 1/2, so the square root of x from both of those, and it equals limit. Which that then equals square root of 25 over square root of 1, which then equals 5. Y'all see what I did there? I pulled out an x to the 1/2. That's the greatest power in the denominator. So the square root of x, I pulled that out of there, and because when you divide by it, take out a square root of x, on the inside you take out a x, because if you take out an x squared from the inside, you take out an x from the outside. So so you pull out a x from the inside, and that turns into x to the 1/2 out here. And because that's all under a radical, you could have just divided everything by x, and it would have said the same thing. Oh, with these, when I plugged them in, yeah, when you plug in infinity in the denominator, it becomes 0. So that equals. Does that make sense now? What do you mean? Trying to do this with limited room sucks. So times square root of x times 25 plus 1 over x over square root of x times 1 plus 1 over x. Does that make it any better? Yeah. Okay, and the limit, and you can split up, since these are multiplied, you can split them up and you get the x to the 1/2. Any other questions over this one? All right, we got one more. Given that x is greater than 0, find the maximum value of x, if any. So we're going to say f of x, I'm going to say y equals x to the 1 over x to the 6th. Yeah. So solving this, you got to use logarithmic. So we're going to do natural log of y equals natural log of x times 1 to the x to the 6th. So I don't know if I'm doing this one right. So taking the derivative, we get y prime over y equals x to the negative 6 times 1 over x using product rule plus natural log of x times negative 6x to negative 7. So this is a negative 1, so that's x to the negative 7th plus a negative 6x to the negative 7 times natural log of x. We know what y is. No, y'all are going to get confused. Y times x to the negative 7. Oh, wow. So is this problem was on the quiz? That's your derivative, I believe. I'm going to go to MathWay real quick. I'm going to finish this problem. I did that wrong somehow, some way. Okay, yeah, I did that wrong. If y'all want to go ahead and leave, y'all can. I'm going to keep recording until I figure this one out. Okay, so apparently there's this special rule that says a to the b equals e to the b natural log of a. So your b right now is 1 over x to the 6th, so y equals e to the 1 over x to the 6th times natural log of a, which is just x. So now we use chain rule. Y prime equals e to the 1 over x to the 6th natural log times derivative of this. So that's usually, if you gotta use quotient rule for that one actually. The derivative of that is -6 natural log x plus 1 over x to the 7th. So this is a pretty gnarly problem. I'm going to skip the simplification because that's ridiculous right here. But apparently it equals x to the 1 minus 7 x to the 6th over x to the 6th times -6 natural log of x plus 1. And now knowing that, what was the question again? Now we got to set that equal to 0. Okay, yeah, I'm sorry, I don't know how to solve this one. Was this actually a question on the quiz? We're going to assume that this term is always greater than 0. Although it's not really, the denominator is always positive. But if that turns to 0, then this turns to 1. So this one's always, that whole term's always or never equals 0. We'll do that. So now we have -6 natural log of x plus 1 equals 0. So natural log of x equals 1 over 6 e to the close. Why is it e? I'm going to go out on a limb here and say it's a. That's just my best guess. If you plug in 1 natural log of x A natural log of x equals 0. X equals 1. Yeah, I'm sorry. That's going to be it for today. Sorry I got stumped. It's not even still sharing. I'm going to assume it's A. So I got stumped. I'm sorry. Have a good day, guys.